welcome to this first video in this new series I decided to create for you guys, Network Programming in Rust. We've walked down that path before with Python. Now we will attempt to do it with Rust. This is actually based on a couple of requests that I have received from you guys. So I thought to myself, why not? Let's do it. And if you're new to the channel, thank you so much for stopping by and clicking on that video. If you like my content, please feel free to hit that subscribe button. And if you're already subscribed to the channel, thank you so much for supporting me during those years. Rust, as you might know, is a programming language that has been gaining a lot of popularity lately. It's not just for building regular apps. It's also fantastic for creating super efficient and scalable network applications. So let's dive in and explore what it has to offer. But before we dive into Rust networking, let's get our basics right. Think of it as the ABCs of networking. First up, we've got TCP/IP, the brains behind internet communication. It's what makes sure your messages get to their destination safely and in the right order. Then we have got sockets. These are like the mailboxes of the internet. They let you send and receive data, just like you send and receive letters in a mailbox. We have also the client-server model. Now picture this. You are at a restaurant. The waiter takes your order and brings your food. That's basically the client-server model in networking. Clients request stuff and server serve it up. And hey, what's a party without some rules, right? Network protocols are like the rule book of the internet. HTTP, FTP, SMTP, these are some of the popular ones. And of course, let's not forget about our addresses and ports. IP addresses are like your home address. It's unique. Ports, on the other hand, are like the rooms in your house. Different applications use different ones. So now that we have got our networking basics down, let's talk about Rust's toolbox for networking. The first one on the list here is the standard library, stdnet. This provides you with everything you need to handle TCP and UDP sockets, IP addresses, and ports. It's like a one-stop shop for network stuff. Then we have Tokyo. This is a superhero of sorts for asynchronous network applications. Tokyo makes things super fast and efficient, and I might create a tutorial following this one on Tokyo. Just let me know in the comments below if you're interested to see that. Number 3, Hyper, which makes creating HTTP clients and servers a breeze. And if you're into real-time communication, Rust has got WebSockets libraries that are perfect for building chat apps or anything that needs instant updates really. And last but not least, if you're dealing with databases, Rust has got you covered there too. So libraries like Diesel, SQLX, and Rustclite makes it a walk in the park. Alright, that's the end of the introduction. Now, let's go ahead and put our knowledge to the test with a real example. And for our code demo, I'm going to use VS Code, but feel free to use whatever code editor you like. Alright, welcome back. So let me go very quickly to the folder where I want to create my project. So I'm going to call that folder, let's say Rust TCP. I'm going to change directory to that folder. And for the sake of simplicity, I'm going to use just or create a simple Rust file. So if you are working on Microsoft Windows, you might want to type new -item. That's the equivalent of touch in Mac OS or Linux, okay, to create files. And I'm going to call that file tcp.rs. RS, of course, is the extension of Rust. Okay, so we have our Rust file, and let me actually open our directory in Visual Studio Code. And by the way, guys, this is the first video in this network programming series in Rust. All right, so let's start by importing the necessary modules from our libraries. So I'm going to write a lot of comments for each code line for those of you who are not familiar with Rust programming language. And by the way, I have a crash course for Rust programming language, and I also have a playlist of 10+ videos explaining the different functionalities and properties of Rust programming language. And I will leave the links to those videos in the description below. Back to our code. So here we want to import the necessary modules from the Rust libraries. So to import in Rust, we use the keyword use, and here the standard IO or input output, and these are the modules that we want, the read and write. Okay, so this is the library, the IO, the input output library, and these are the modules, the read and write. And similarly for networking operations, we want from the net library, we want to import also two modules, the TCP listener and the TCP stream. Okay, we are going to use those in our code. Next, we want to create a function that will handle the communication with a connected client. So to create a function, of course, in Rust, we use the keyword fn. Like def in Python, function in JavaScript, in Rust, we use fn. The name of the function, handle underscore client, and this function is going to take immutable reference, so stream here, to a TCP stream as an argument, as an input. Okay, TCP stream. So basically this function will handle the communication with any connected client. And as I will show you in the demo later, when we will open different browsers, this function will handle those multiple browsers, those multiple connections on port 8080. So don't worry, we will see all that later. Next, I want to declare a mutable array named buffer. So let mute, again, all of these keywords, all of these small nuts and bolts in Rust language, you can learn about in my Rust crash course. So I'm going simply to define or declare a variable called buffer that's going to be mutable array, and we're going to give it a size of 1024 bytes. Semicolon like that, and 1024, that's the number of bytes that we want to, or that's the buffer is used to read data from the client. Okay, so again, let me just add a quick comment here. So I will say this is a buffer, not bugger, this is a buffer to read data from the client. Next, we want to read data from the stream. So I'm going to type stream like that and access that method called read. And if you're coming from Python background, this might look weird to you, mute and ampersand mute buffer. But in plain English, this here reads data from the stream or the client's connection, in other words, and then it stores it in the buffer. All right. The read method here returns a result. So this result will indicate the success or the failure. So we are going to use a method called expect, and expect is very popular in Rust. That's a method that it's used to panic with an error message if reading failed. So simply is going to throw you an error with whatever error message that we're going to type here. So let's say failed to read from client. Nothing is really complicated, even if you're not familiar with the Rust syntax, because really we have walked down that path with Python. I don't see big deal learning the syntax of a new language. If you're already familiar with the logic in one language, that's more than enough for you to go and learn other languages, because most important here is the logic. The syntax can be, taught very easily. A small toddler can learn by heart the syntax and write good code, but understanding what's behind the code, that's what's more important. So let me just write a little comment here. So we'll say this line reads data from the stream and stores it in, or stores it in the buffer, right? In the, I keep saying bugger, in the buffer, all right. All right, next I want to convert the data in the buffer into UTF-8 encoded string. So to do that, I'm going to declare another variable. I'm gonna call it request. And here I'm going to use the string, and there is a method called from UTF-8 lossy, from UTF-8 8 underscore lossy, and I'm going to just pass inside here open close square brackets, 2 dots like that. And by the way, I've forgotten to yeah, okay, so only here, because very often when I write in Rust I forget to write or to just terminate the sentence or the expression or whatever, the code line, right, with the semicolon. Rust is a semicolon type of language, so keep that in mind. Okay, so simply this line, what it does, it converts the data in the buffer into UTF-8 encoded string using this from UTF-8 lossy method. So this method actually, it handles the invalid UTF-8 data, right? It replaces the invalid sequence with the Unicode replacement character. So this method basically handles the invalid UTF data. Okay, so again, let me just write a very quick comment. Let's say this line converts the data in the buffer into a UTF-8 encoded string. And finally, we want to print the received request from our client to the console. So print ln, and we'll say here received request, open close curly braces. That's a placeholder for the actual request to be plugged inside that curly brace. All right, so that's our handle client function. Also, I want to create a response variable. We'll say here hello client. We will use the as bytes, or we will invoke the as bytes function. So this line here simply prepares a response message that's hello client, and then it converts it into a byte slice using this as byte method. And this simply allows us to write it to the client as row bytes. And the final line in our handle client function is that I want to write the response to the client's connection. To do that, again, I'm going to take the stream like in line 9, but instead of read, I'm going to write method, and I'm going to pass in the response. And again, I'm going to use the expect method to throw any potential error. So we are going to hard code our error message as we made in line 9. So I'll say failed to write response. Okay, and that's simply our handle client function that I'm going to use basically in our main function, in our entry point. So let's go ahead and write our entry point. That's our main function, of course. So I want basically to bind the TCP listener to our address, our localhost port 8080. So to do that, I'm going to again declare a variable. I'm going to call it listener naturally because I'm going to use the TCP listener, and I'm going to bind to that the localhost 127.0.0.1 on port 8080. And then we're going to use the expect method where we can say something like failed to bind to address. Okay, so that's the first variable in our main function. And again, I want to print line. We'll say server listening on 127. All right, that line simply prints this message to the console to indicate that the server is listening. Next, what I want to do is I want to loop over the incoming connections. So I'm gonna use the for loop, of course. So for, let's say, stream in listener dot incoming. And then I want to use the match expression, so match stream, and I'm going to, what I want to do is to handle the result of that listener.incoming. So again, this line starts a match expression to handle the result of listener.incoming. This result, if established successfully, will contain TCP stream. And if the connection is established successfully, the match stream will be executed. And then here I want to use the handle client function. And simply we want to use std thread spawn. What does that mean? This simply means that we are spawning a new thread using this standard thread spawn. And inside this thread, we will call on our handle client function. Then I'm going to type parallel pipes. So this parallel pipes here, this is a closure in Rust. And closures are simply anonymous functions that can capture and use variables from the surrounding scope. So in our case here, this parallel pipe syntax defines an empty closure with no input parameters, right? Then space, then our handle client function, and we're going to pass inside the stream as an argument. So finally, I'm going to use a pattern match. So that's ERR, and I'm going to pass inside E. So that's typically used to handle the case where the result is an ERR. That represents an error condition, by the way. So in our case, that E here, this is a variable that will be bound to the value inside the ERR variant of result type. Okay, and then after, I'm going to this is very familiar to you now. So we will return the printing. We're going to print a message saying something like failed to establish a connection, but not print. Instead, we'll use ePrint ln and exclamation mark like that. And we'll open parentheses and we'll type failed to establish connection. Again, open close curly braces, and that's the E that's going to replace or for the placeholder here. So you might be wondering why ePrint ln? That's a macro to print an error message to the standard error stream, stderr. This is actually the standard error stream, and that's why we have written ePrint, or we have printed using the ePrint ln, because that's a macro that prints an error message to the standard error stream here. So all in all, what we have done here, or this code sets up a simple single-threaded TCP server that's going to listen on port 8080 as we have defined in our code, and it's going to accept incoming connections and responds with the hello client message here to each client. And then we use basic error handling and spawns a new thread to each client to handle multiple clients concurrently. All right, so again, I hope this is clear for you, and let's put our code to test. Let's open our integrated terminal and run our program. All right, so I want to compile my tcp.rs into an executable. To do that, I'm going to type rust c, and then I'm going to just type the name of the file, tcp.rs, flag A warnings. We can delete that, that's not important. We have got an error, help use a double colon instead. Let's take a look what we have done here. Oh, I forgot. So let's repeat that one more time. Let me just do clear first. So let's do again rust c tcp.rs, and we should have, or it has compiled to tcp.exe. That's an executable file, a binary file actually. Okay, so we cannot see anything here. To run our file, we will simply type .// TCP, and there we go. The server is listening on localhost port 8080. Now let me open Google Chrome, for instance, here, and let's check out 127.0.0.1 port 8080. And immediately you can see that there is a connection that has been established. Received request, and that's the GET request. And that's the host, perfect, and everything else. That's the name of the search or the browser, which is Google Chrome. All right, the user agent and all the other information. Let me open now Microsoft Edge. That's another browser. Again, 127, 8080. That's another connection successfully established. We can see here that that's the name of our browser, Microsoft Edge version 117. The user agent, all right, accept text HTML, blah, 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 all of that. All right, so that's the end of it. Thank you so much, guys, for watching. And if you want to see more of those network programming in Rust programming language, please let me know in the comment section below, and I will see you in the next video. Till then, stay safe and be well. Take it easy, guys.